Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I appreciate the fact that you are watching. Today, everybody, we're going to get started out by doing something just a little bit different here. I want to do a little bit of a demonstration of the way that I would handle the grid project that you turned in last week, right? So I waited until after you all, turned it in and got it graded and all that kind of fun stuff before I demonstrated kind of the way that I would handle it. And then after that, remember Module 4 is due today. We'll start covering Module 5 material in the live stream today, which is, we're kind of shifting gears from recursion, which we started talking about last week, and I will do another brief recursion thing, just so, we can kind of flow into the idea of iteration, which is what we're talking about in Module 5, just to kind of, bring about a little bit of, give us a little bit of review and then kind of bring about a little bit of cohesion between modules 4 and 5 so we can see how they work together. But first, what I want to do is I want to look at that grid code. And so I challenged you all in the assignment to try to make it as short as possible. Use a function to make that grid and try to use as little code as possible. in order to do so. And, by and large, as I was grading, everybody was successful. We talk about, being at a different level, right? Getting started, learning how to program. What I saw from the vast majority of you all was A-okay, just fine, right? As long as you used a function and you put the different things in the function, right? We just wanted practice doing a function and all that kind of stuff. But I want to show you the way that I might approach something like this, and it's very different. And it not only can make the grid that you saw that I asked you to make in the lab assignment, but you can modify the parameters of it to make it a bigger or smaller grid without having to change the code. And it's done in fewer lines of code than the vast majority of what I saw out of everybody there. So again, it's just a different way to approach the problem. It's a more advanced way to approach the problem. And it's something that we would get to when we get there. But in saying that it is a more advanced way to approach the problem, I'm also not going to be using anything that we hadn't talked about up to that point. Every single thing that I'm going to include in my code here is going to be something that we at least talked about to some degree up to that point. Right, so I'm going to add my shebang statement here, hashbang /usr/bin/env Python 3. And I'm going to create my grid function. We're going to define a grid here. And I'm going to add 2 parameters to this. So I'm going to put in 2 variable names here in my parentheses, a C for columns and an R for rows. So this way, when I call my function, I can define how many columns I want and how many rows I want, and it can print things out accordingly, right? So it can give me my nice grid. And so what I kind of want to do here is I kind of want to break this down into segments. So I can look at each segment on its own, right? Because it's repeating patterns. So that's a big thing that we can kind of see out of this, is that we have repeating patterns that we can work over and over and over again. And if we can work repeating patterns out over and over and over again, then we can kind of figure out how to do bigger things. So we can see that that grid is kind of built of 2 different sort of repeating patterns, right? There was the one that looked like this, and the one that looked like this, right? With the bar and the spaces and the plus sign and the dashes. So let's create a segment that would create both of these. And I'm going to kind of simplify the amount of code I need to write by using the repetition operator that we learned about way back when. So segment 1, I can represent as a string of the plus sign being concatenated with space dash space times 4. Right, so that's going to repeat my sequence of space dash space 4 times and concatenate it with the plus sign. So if we print this, print seg1, and we call our function, so it runs. We do need to call it with parameters, even though we're not using the parameters yet, so it won't error out. So I'll just put 1, 1 in here for the time being. We can run this, and we see we get that segment. Right, so we can go a little further here, right? And we can make that into the entire line. Right, so if we want to make line 1, well, that's going to be our segment 1 repeated columns number of times plus the little bit that goes on the end, right? So we're going to concatenate it with the little bit that goes on the end, which is going to be space plus, and then 2 new line escaped characters. So that's /n/n. And so that's going to, 1, break it to a new line, and 2, leave an empty line, right? Because if you remember back to the course, when we think about it, like it had a space kind of between the rows as well, in addition to having a space between all of the items there. And so this is our line segment. And so now we're using that column value. So if we enter line 1 here, this column value matters, right? So if we run this now, we get a singular column, right? But I think the one in the module used had 3 columns. So if we change that to a 3 there, then we get the entire line, right? Going all the way across 3 columns, you can see it being utilized there. So then we can basically do the same thing with the other segment, right? So we can say, okay, seg2, that's the bar with the spaces. So we're going to set that equal to our bar character plus, and so since the first segment is space dash space, this is just 3 spaces, space, 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 times 4. And so that's segment 2. And then line 2 would look similar, right? So line 2 is going to look similar to line 1. We're going to set that equal to segment 2 times the number of columns plus the ending character again, which is going to be space, bar, new line, new line. Right, so now we have segment 1 and segment 2. So if we were to print these out kind of on separate lines here, we can print line 1 and line 2. And so we can, oops. Oh yeah, I forgot to put C there. I should put C there. Yeah. And so we can kind of start to see this emerge. Right? It doesn't quite look right yet, right? Because we're not doing everything together yet. But once we do everything together here, we'll see it kind of emerge out. Right? So what we want to do here is we want to make another variable for our row. And so the row will do 1 line. The spacing in the middle. However many times we need that to be done. And I actually need it to be done twice here, so I technically need this to go times 2. We'll look at that in a moment. Right, because there are 2 of these. So let's go ahead and add a times 2 here. Getting a little bit ahead of myself. So we can wrap all of that in parentheses so my interpreter reads all of it together. And then we can do a times 2 to double it up. So now if we run that, we can see we have the 2 rows there. And we might need to do a little bit of adjusting, right? I'm kind of doing this on the fly here. So we can go back and do a little bit of adjusting if we need to get it perfect. Right, so now to get a row, we need this line. We need these 2 lines. And we need the line again, right? Because that was the way that it was set up. So to get my row, I'm going to create a line 1 plus line 2. So we're going to concatenate these items together. So we have line 1 and line 2 together. Then we're going to multiply that by our rows parameter, right? So that times R. So that will give me a number of rows. And then we'll concatenate to that, since there's a repeated line 1 across the bottom, we'll concatenate to that line 1. And so now if we print out row, that's essentially what we're getting here, right? So we can look at this like so, and there is basically one row that looks exactly like it did in the module. We can see we have spaces between the horizontal dashes. Everything looks good there. If I want to get the exact grid that I have in the module, well, it was 3 columns and 2 rows. So I can change my row value here to 2. And I get my grid the exact same way I kind of drew it out in the module. And so the big thing here, right, is that not only do I have this grid, which is great, but I can change it up. Let's say I want a bigger grid, right? Let's say I want 5 columns across. And 4 rows tall. Right? So instead of changing any of this code, which, you know, if you just printed out the rows the way that some of you did inside of your functions, you'd have to do that. I can just change my parameters and bigger grid. Right? So I can make an enormous grid or I can make a tiny grid, and it's all based on whatever parameters I enter in, and it looks like the grid that's in the module. Right? So it can be a 1, it can be a 1, 1, which would be just a singular cell. Right? Just looks like that. It could be a 10, 2, so it's 10 across and 2 wide, and or 2 high, and I'll make my console bigger for this. Right? And we get that as well. And so that's one of the benefits of being able to do this, right? At the end of the day, it is a 3-2 grid that's represented there, and we can just get our 3-2 grid there. And so that would be the way that, you know, as somebody who has been programming a while, right, who wants to focus on modularity, being able to reuse something, being able to have more purposes for something, that would be the way that I personally would approach a problem of that nature. Right? And so we can see here, I've only actually written about 6 lines worth of code, 8 if you count where I define my function and where I call my function. Right? And if we look at here, you know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Like you could do that in 13 print statements. Or I can do it in 8 lines of code this way and have it be flexible. Because now I can make a grid of any size with this. But, you know, that is the sort of difference that we get into, that when I say, you know, certain things come with experience, right? Being able to see problems, break them down from a smaller problem, you know, work your way up to the bigger problem from the small problem. And so as we're starting, right, there's no issue with, you know, making a series of print statements inside of a function and calling it a day, right? Like that's what I would probably do too. But once you get more advanced and once you're able to see the problems a little bit differently, and you understand kind of the usefulness of modularity, then you're able to start to work through problems in this sort of way, and they're way more flexible and way easier to handle. And I will point out as well, right, that there's nothing here that we didn't at least talk about, at least mention, you know, whether it was in a live video or in the module at some point between the start of the semester and when this was due. Right, everything we at least mentioned somewhere. Right, like I think the most obscure thing in here that we didn't really spend a lot of time on was the escape new line character. I think we maybe mentioned that. really briefly. But everything else, we see the repetition operator, we see concatenation, we see variables, a function with parameters, right? Nothing that we didn't handle together. So with that being said, let us kind of move into today's stuff now. I'll create a new REPL here. That'll be nice and clean for you all to see. And so last week we started talking about recursion, right? Recursion, the assignment that's due this week looks for you to employ recursion. And we started demonstrating and working with recursion last week. And one of the things that we said as we were beginning our discussion of recursion is that recursion, I'll share it out. I will share that out, that grid code. And so one of the things that, we started talking about when we started talking about recursion is this idea that recursion and iteration are two different beasts, that we can basically do some of the same things with both recursion and iteration. However, there are some instances where one would be more efficient than the other. And I think by and large, especially as, people who are, getting started with programming, you're gonna be more fond of iteration than recursion, because recursion sometimes requires us to kind of put our thinking caps on in terms of how we kind of are passing data through our function, because if we're not careful about it, it can reset the data values and going off into an infinite recursive loop and all that sort of fun stuff. But if we remember back to last week, and I'm going to do just a little bit of review about recursion here, and then we'll use that to kind of be a foil against some iteration when we get to that point a little bit later on. We talked about the idea of recursion and a recursive call, right? And that when I write a function, I can call that function literally anywhere. I can call it behind the main gate. I can call it just on its own. I can call it within another function. I can call it within itself, right? And it's that function call within the function itself, right? So if you're calling a function inside of itself, that's a recursive call, right? Because the function is running itself. So if I defined a function here and I called it recurse, in order to have this, we need to have data values. And there is a little something interesting in Python that I didn't talk about last time that I think is maybe interesting to mention, and that is the optional parameter. Right? So normally I set some sort of upper limit data value. So like, for counting to 10, let's say, I have an upper limit data value. We'll represent that as u here. And then when I call that function, I'm going to call it with the upper limit data value. Now, if I want to start at the same number every time, I can define a function that, has that same number in it all the time. Or I can define an optional parameter. So in this case, what I might want to do is we'll take our b, our bottom number here, and as a part of the parameter, we will set it equal to 1. Right, so what we're doing here, normally if we didn't set this, right, when we called this function, we would have to call it with 2 values. We would have to call it with 1 value for u and 1 value for b. But if we assign b a value as a part of the parameter here in Python, then it's going to, if we don't provide a value for b when we call this function the first time, it is going to assume that it is a 1. So it's a good thing to kind of start it out with here, right? So from this point, right, I can take my two values here. I can write my conditional statement. If b is less than or equal to u, then we'll do the thing, right? And let's do even odd today. So let's say if it's odd, we will print out the number. And if it's even, we will throw some kind of emoji in there, right? So we'll say if b modulo 2 not equal to 0, then we will print b, else we will print some sort of emoji. So let's throw the brain in there, the brain emoji. Let's get that away. Let's throw our brain emoji in there. And so then the only thing that we would need to do from here, right, to make our recursive call would be to call this function inside of itself, right? So if we put this in here, we want to make sure that it is inside of this conditional statement here that's looking to see if b is less than or equal to u, because that's what's going to stop it. Once b passes the value of u, that's what's going to stop it from running. Right, so we can put that here. We can write our recursive call. And our u value is going to stay the same, so we can pass it through untouched. But our b value, in order to get it closer to u, we need to manipulate it somehow, right? So if we were going down, we would subtract here, but since we're going up, we're going to add here, right? So we're going to say b plus 1. Right, so if I'm just calling my function, I don't have to worry about this. If I want this to be 1, I don't have to give it a value for b. But if I want it to be something other than 1, I need to give it that value. So after the first time it runs, it's going to hit this point here. B is going to turn into 2, and then it will run again with 2 in that position. So now if we call this function, and so let's put our main gate here, if underscore underscore name underscore underscore equals in quotes underscore underscore main underscore underscore. We're going to call our function, which we're calling recurse. And we're just going to give it the u value, right? We're going to give it to where we want it to stop. So let's say 20. We don't have to define the b here because the b is assumed to start at 1 if we don't define it, right? We can define it at 2, 3, 4, whatever, and it'll start working from there and override this. But if it's not listed, then it'll just start from its assumed value, which is 1. And there we have it, right? So we get 1 brain, 3 brain, 5 brain, 7 brain, 9 brain, 11 brain, 13 brain, so on and so forth. Right? And so one of the good parts about using functions as well is that I don't have to comment out all of this. I just have to comment out this for when we do our other examples later on. And so that's kind of, that's also kind of the gist behind what you'd want to do for your lab assignment as well, the Bing Whiz Pop, right? The idea that we're checking things for whether or not they evenly go into one another, right? Which is similar to the way that we checked it here for odd or even, right? Just check to see if it's, if the modulus that is a result of a modulo problem by 2 is not 0. If it's anything other than 0, then it's going to be odd. Otherwise, it's going to be even. And so on and so forth. And so when we talk about iteration, in contrast to recursion. There's a lot of stuff for us to talk about. So let's get into a few slides here for just a little bit, and then we'll come back to this example. I'll do an iterative example that we can kind of put next to our recursive example so we can see these things side by side and have this understanding of, well, okay, like, yeah, that and that, right? That's kind of the way that these parallel to one another. So we can talk about some slides for a few minutes here. And as we're beginning iteration here, we're specifically talking about while loops. And so while loops are kind of our bridge between recursive calls with conditions and just iteration in general, right? We'll talk about the for loop in the next module when we're talking about string manipulation. More specifically, we'll talk about the enhanced for loop. But as we're kind of getting started with iteration here, everything that we're doing iteratively can be done with a while loop, a while loop and a for loop. If you've heard of for loops before, a for loop is just basically shorthand for a while loop, so you don't really have to remember as many things, right? They're all just kind of built in there for you. So as we're talking about while loops here, starting with while loops gives us a better understanding of just what's going on as we are working with this iteration, this loop. Right, so one of the big things that we need to understand first is something that we kind of talked about earlier on when we talked about variables, so just to kind of touch on that again, right? It's this idea of reassignment. Right, whenever we take a data value and we put it inside of our variable container, we can take it out and replace it, right? And so when we're talking about reassignment, that's basically what we're talking about here, is we're talking about the ability to reassign the value of a variable. And we can kind of see that with our recursion there, as we're going through, right? And it's making that recursive call. It's changing the value of that parameter and adding 1 to it, or subtracting 1, or adding 2, or whatever you want to do with it, right? It's manipulating that value some way. So this is another place where just the idea of variables in general becomes exceedingly powerful, because we end up with, values that can share a name, right? We can use one relative name for the values, but the value itself can change over time. Right, so in the example here, we set x equal to 5. Then if we examine or evaluate x, it's 5. But then if we reassign the value of x to a new value, we've taken that 5 out. We've put a new value in, which in this case is 7. And so when we evaluate x the second time, x is now 7, right? Because it is reassigned. And so this is updating. The variable. Or it's one way of updating a variable. But a common way that we update that we change variables is through an update. So when we're talking about an update in this sort of way, the value of the new variable is dependent on the value of the old variable. And that was kind of what we were seeing there when we were looking at our recursion, right? The next value for b is going to be, whatever. +1 or +2 or -1 or -2 of whatever it was previously. Now, one thing to note is that variable has to already exist before you try to update it, right? Remember that everything goes from top to bottom, left to right. So if your program gets to a point in its execution where you're trying to increment the variable or update the variable, like we see here, x equals x plus 1, and it doesn't have a previous value, then you're going to get a big error code. Because at that point, x doesn't exist, right? It doesn't exist until you assign it a value. That takes us back to our discussion of variables a couple weeks ago. In Python, the variable doesn't exist until you give it a value. So I can't add 1 to a value that doesn't exist, right? That's why it's going to pitch a fit. So if we start with a value to initialize our variable, then incrementation becomes easy, right? I can take whatever value's in there and I can add 1 to it. We see that in the 4th bullet point here. Right? Instead of just jumping directly to x equals x plus 1, we start out by just putting a value inside of x to instantiate the variable, and then we can increment it to our will, which is ideal. So let's talk about a loop and just what exactly is a loop. We kind of looked at the idea of looping last time with the idea of recursion, right? But a loop is not a recursive call, right? We're not calling a function from within another function. But we still have this process that allows us to take and repeat a process until a condition is met, right? The same sort of thing, right? We can kind of put the logic in the same area. Just we don't have to use the recursive call in order to be able to do it, right? Because we're still using a condition, and we're still using a value that needs to approach the point to change that condition from true to false. Really, the while loop the way that we can kind of think about our while loop is very similar to the way that we think about our if statements from last time. Right, with our if statement, we basically said, well, this is going to run if this condition is true. And our while loop is basically saying, this is going to run while this condition is true. Or this is going to run as long as this condition is true. So it's going to keep running the same block of code over and over and over and over again until it gets to the point where it has that condition break. And when that condition breaks, the loop will stop. It'll move on to the next thing. Right? So when we get to sorting, which will be the last module of the semester, right, we talk about algorithms and we talk about complexity and all this sort of fun stuff. When we get to the idea of sorting, we're oftentimes using loops and various things for that because we're taking a big set of data and we are converting it and working and performing the same action to every part of a big set of data. So that's one of the big key things that we can use a loop for. Something that we want to do over and over and over again multiple times just to save us effort. Right? And so iteration just means executing the same block of code over and over and over again. And this is a programming structure or a loop is a programming structure that implements iteration, right? And so what this is doing is it's sort of changing our flow of execution just a little bit, right? Like the way that we kind of worked with recursion is, we have this understanding that when function calls happen, it's going to start that function at the beginning of the function and run through it. But now with iteration, just in the middle of a function, we can kind of take this little side road and we can start to loop over a block of code multiple times that ultimately ends up with us doing the same action multiple times, right? And so in programming, there are two types of iteration. There's indefinite and definite iteration. And with indefinite iteration, you are looping code until a break is reached. Right? We typically use what we call flag variables for indefinite iteration. Right? So we don't know how many times our code is going to loop ahead of time. We know that it might loop forever if something doesn't happen, right? There's no set number of times that something can be iterated prior to doing it. And then there's definite iteration where we kind of set a number of times. We know that this particular thing is going to run 3 times, let's say. And we'll do an example of each of these when we get back into our examples here in just a few moments. We can write while loops that are both indefinite and definite. It all just depends on how we choose to write them. So with a while loop, again, we can execute a set of statements as long as a condition is true. Right? So if our if statement says, if this condition is true, we're going to execute this code. Our while loop says, as long as this statement is true, we are going to execute this code. And the while loop requires relevant variables to be ready. Right? So we actually have to, what we call, seed the loop. We have to have a point to where the loop can start. So we still have to kind of treat it the same way as our recursion, where we have this starting point and this ending point, and we want to take our starting point and move it toward our ending point. Whatever that means, right? Like if we can kind of think of it as, when we're talking about indefinite versus definite iteration. For definite iteration, you know that your destination is 20 miles away. Right? So once you travel from your starting point, you travel 20 miles, you get to that ending point, and that's definite iteration. Right? You know that when you get 20 miles into your journey, you're going to be where you need to be. And then you can stop. With indefinite iteration, you know that if you keep following this path, your destination is there, but you don't know how far away your destination is until you get there. So you still have a starting point, and you still have an ending point, but the amount of time between the starting point and the ending point is unclear. Right? Maybe something is going to continually run until, say, a level sensor gets triggered. Right? If you're doing an industrial application. Right? For example, I might need to open up a steam valve if the contents that's in a container gets to a specific temperature. Right? So I need to keep running my loop to keep checking that temperature. I don't know when that temperature will be reached, but when that temperature is reached, I want to be able to stop my loop and open up the valve. Right? Another instance in where we use indefinite iteration is with video games. Right? We have something called a game loop that we talk about, in game development. And so, you're basically running actions until the character hits a situation that terminates the round. Right? Whether they win or whether their character is eliminated or whatever. Right? So you don't know when that time will come exactly, but you know that if one of these conditions gets met, then that's when it stops. Otherwise, you say, oh, well, I need to do this 10 times or whatever. And so we can kind of look at our while loop like this, right? We enter into a while loop. We check the condition. If the condition is false, we break out of our while loop. If the condition is true, we do the statements that belong to our while loop, that are inside of our while loop, and then we push back to the top and check that condition again. And so let's do just a couple small examples here. of some while loops. Let's do an iterative one, and let's do a definite one and an indefinite one. I should say. So let's start out with a definite one, because a definite one is easier to for us to comprehend, right? So I'm going to create myself a new function here. I'm going to define a new function. Well, let's call it definite. And we can use a parameter here. We don't necessarily have to, as we're kind of looking at what we're doing here. I'll use a parameter for the upper boundary here. So we can call it u. Remember, the parameters are scoped to the function, so u in our recurse function is different than u in our definite function. And so now I want to kind of come up with my starting point. So let's call it s here. My starting point is going to be 1. And so if I know that I want to get s to u, I know that I can say, while s is less than or equal to u, right? And our while statement has a colon in it, right? Which, as we've said in the past, any statement that has a colon in it has other statements that belong to it, which means that we need to indent items underneath this. We can print the value of s, and then we can increase the value of s. And in Python, we use the shorthand of s plus equals 1 to increment the value of s. That's basically the same as saying s equals s plus 1. Right, so even though this seems indefinite at the moment because we don't know the value of u yet, as soon as we define that value of u, it becomes definite. There is a specific number of steps that's going to happen here until this stops. Right, so if I call this definite function and I give it some kind of upper limit, like let's say 10, it's going to run what's inside of my statement there as long as it's true. So if I run this now, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? S starts out as the value of 1. 1 is less than or equal to 10. We print s. We add 1 to the value of s. We go back to the top of the while loop. Now we can probably see what makes this beneficial, or maybe simpler for us to use, in relation to our recursive call, right? We're basically doing the same things, right? Like if we take this here, we can kind of break it down, right? We still get our u value. We're still checking this condition, right? We're still taking another value and we're incrementing it. Right? But the benefit to us here of using something like this is the fact that we don't have to make this recursive call. We don't have to wrap our brains around how we would properly call this function again from inside of itself to get it to recurse properly. Because automatically, when it gets done with all the statements that belong to the while loop, it's just going to jump back up to the top of the while loop and check that condition again. Now, again, we do want to do something like this where we are incrementing the value of s because we do want to bring that starting point to be closer to our ending point. Right? If we don't increment the value of s in some form or fashion, it's going to leave us with an infinite loop, which is going to cause us problems. Now let's look at an example of an indefinite loop. So def indefinite. And we can have some sort of value here. but we don't necessarily need to bring one in for our indefinite loop. And in fact, let's just kind of do something just a little bit different. Let's generate a random number. And it's going to be a pseudo-random number, right? Because in Python, random numbers aren't really random. So I'm going to import the random library, import random. And we'll even import it as with an alias. You know, we talked about this when we talked about the math library. We talked about how we can add an alias and that can truncate down. So import random as R. So in my indefinite function here, I can create a random number, right? So what I want to do is I want to start out by creating my variable, or I don't necessarily even have to create a variable here. I can just seed the loop with a true Boolean. So I can say while true, and so notice here I don't have an ending point, right? I'm just saying while true. And so let's get a random number. We'll say n equals r dot rand int between 5 and 15. And so if n is greater than 10, we are going to break. And so when we break inside of a loop, that means we are stopping our loop. We are breaking out of our loop. Else, we're going to print the value of n. Right, so what we're doing here is we've just created this loop. By default, it is an infinite loop, right? Because it is an indefinite loop. It doesn't have an upper bounds like our definite loop does here, to where we can take this s variable and keep marching it up toward, right? We're just going to keep on generating random numbers until one of them gets over 10, right? And that could be immediately, right? The very first number could be 11 and it could be done. Or it could be forever, right? Like it could be almost infinite, because, you know, it all just depends on the random draw. So if we run this now, and that we need to call it before we run it. So let's run indefinite. Indefinite. We see, okay, first time it didn't print out anything, presumably because the very first number that it gave us was over 10. Let's run it again. Okay, so the third time we ran it, we got a 9, and then it stopped. And maybe we can kind of, let's make this number value a little bit higher here. Let's make it 13, just so we can kind of see it go more and more and more and more before it stops, right? So there we see, okay, we got 7, 5, 6, 11, 11, 8. Well, if we run it again, we get just 12. If we run it again, we get 5 and 10, right? There's no definite amount of loops that this loop is going to make. It's just going to loop until this subcondition is met, and then it's going to break. And so this is kind of mimicking what, for example, it would look like to, say, you know, be reading a data value from a sensor, right? Or, you know, whatever. Like when it hits that threshold, whenever it is, then we want to be able to break out of the loop. So if we do it a couple more times, we see, okay, we got a bunch there, right? Notice that we get 13 here because it's greater than 13 and not greater than or equal to 13. Which the only things greater than 13, or the only two numbers greater than 13 in this random integer set are 14 and 15. Right, so right there, we got it first try. Right there, it took us 3. Right there, it took us 1. There's first try. No definite amounts of loops through our statements here. Right, the only big important things here is that we start out with true. We start out with some kind of statement that is true. And then at some point, we make that statement false. Right, we do that in both of these examples, in the definite example and the indefinite example. So to kind of get us wrapped up for today, because I think I've hit the big points that I want to hit. What I would like to do is I would like to do our recursive example that we did earlier here, but do it as an iteration. So I am going to define a iteration function, and I'll even bring in the same parameters. I'll bring in u and I'll say b equals 1. U and b equals 1. Now, one of the big differences here is that we can't assume b, right? At this point, b doesn't exist, really. I mean, we can kind of assume it, but we want to be able to assign it if possible. Right? So we can write an if statement here that says, or a while loop statement here that says while b, and I'll wrap it in quotes just to keep it, or wrap it in parentheses just to keep it consistent, while b is less than or equal to u. Right? So already we see some changes here. Right? There's no if statement. The if statement is now a while statement. And we can run this exact same if statement inside of here. So if and what do we say up there is b modulo 2 not equal to 0. We just print b. Right? Otherwise, else, we print our brain. Right, so now all I need to do as a part of this, right, and I want it to happen if either of these internal statements are true, I want to increment the value of b, so I can say b plus equals 1. And so that's it. Right? That's all we need to do here. Right? So now this function here is fundamentally the same as this function here. So when we call this, we can call it in the exact same manner that we called recurse earlier, except here we call it, here we use iteration and 20. And we can run that, and we see we get the exact same results. 1 brain, 3 brain, 5 brain, 7 brain, so on and so forth. Right, so when you get this, you'll have an example to kind of compare side by side our if statement with recursion to our while loop. Now, another interesting thing in Python is that I can also use an else statement with a while loop. Right, which would be similar to the way we would do it here, right? Like if I came down here below recurse and added an else and printed thank you, right? That's going to work. So let's comment out iteration for a minute and uncomment recurse. We can see that gives us a thank you at the end. A normal example that I do similarly is I might count down and do blast off, right? We have a couple minutes, so maybe I'll, do that really quick for you. But in this instance, the while loop can itself have an else statement in Python. So I can else, and I want to make sure that it is in line with my while loop. I can print, thank you. Right, so now these two functions are exactly the same. It's going to count down, it's going to print, or it's going to count up to 20. It's going to do the things inside of the while loop that it needs to do, and then it's going to say, thank you. Right, so really quickly, as we wrap up here, I think maybe we can do a countdown here really quickly. So let's define a countdown. Define our countdown. We'll have an upper limit that we bring in. And let's go ahead and set a base equals 1 here. And in this instance, we want to kind of take our logic and flip it, right? So in this case, we're counting down to 1. So we're going to say while u is greater than or equal to b. So this time, since we're counting down and we're not counting up, we're manipulating the larger number instead of the smaller number. So we are going to just print the value of u, and then we are going to subtract 1 from the value of u. So u minus equals 1. And then we will put our else statement in here. So after that is finished, we can print, maybe with a rocket ship, blast off. Right, and so now if we call our countdown function, and we call it with a parameter of 10, we're counting down from 10, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Right, so we run that, and we see that happen. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. And so that's our entire hour, and we covered a lot of things today. We cover a lot of ground typically in these live classes, but it is, it is still good for you all because, you can go back and you can watch the recording and you can pause and rewatch and do whatever you need to do, right? So it's all there for you. We've seen several different examples of while loops here, which should kind of give you that extra tool, give you that extra puzzle piece. For when you are working on your module labs. So we are wrapping up here, so I will take any questions anybody has. If there's anybody who's here with me live, if you have any questions, we can take those at this time. If you are watching the recording and you have questions, then please send me an email or a Teams message and we can take care of those to the best of our ability. So while we're waiting to see if there's any questions here, this is just a reminder that this is what you'll get today when I post this, and I did forget to click the button, so I won't be posting this video until tomorrow. Because I have to, in these instances, I have to wait on YouTube to process the video, then I can download the video from YouTube, re-upload it on Panopto so you all can watch it. All my CCP students can watch it as well. And it usually takes YouTube a while to get it to where I can download it. So first thing tomorrow morning, I will have the video available and posted, the recording, so you all can watch it. I will have the grid code from earlier along with this sample code here that we've been working on in regard to iteration. And so with that being said, and not seeing any questions in the chat, we'll go ahead and wrap up here for today. I'll hang out for just another minute or two just to answer text questions if they come in with the music going here. So that's all that I have for you for today. Remember, Module 4 is due today. This is Module 5 material that we're talking about here for iteration. So Module 4 is due today. Module 5 is due next week. This is Module 5. I'll edit the YouTube title. That's all that I have for you for today. Thanks for watching. We'll see you next time.